Okay, so as we start, one of the things that's a little bit different in high school math than junior high math, I mean, there's lots of things, but one of the things in terms of what we do for measurements is in junior high, we only ever have to deal with the metric system. In high school, we deal with the metric and the imperial system. And in Canada, we say that we just work in the metric system, right? We're a country that uses the metric system. But then, you know, we realize maybe there's some slight discrepancies, like, hey, Evan, how tall are you? You know, Zach, how tall are you?
5'9".
Notice he didn't answer in centimeters, he answered in feet and inches. Right, he answered in the imperial system, which actually I would have answered the same way, right? We think about our height usually in like imperial. And I won't ask anyone this, but if I ask you how heavy you weigh, you'd probably say how heavy you are in pounds, not kilograms, right? So we are a country where the metric system is our official measurement system, but we tend to sometimes use metric for certain things and imperial for certain things. If you're talking about length, which is what we're going to be doing today, if I'm driving to Calgary, I'm driving on Highway 2, I see those green signs, they say how many kilometers it is, right? Like 300 kilometers to Calgary, 150 kilometers to Red Deer, whatever. But as I'm driving, I'll also pass range roads and township roads. And what range roads and township roads are is basically how our land was initially surveyed and distributed out in Alberta. And you'll see like Range Road 21-1, Range Road 21-2, Range Road 21-3, 21-4, 21-5, and then it'll go 22-0, 22-1, and on like that. And it's interesting. What those are actually marking is every mile. Every mile there's a new range road. Every mile there's a new section of township. And actually the way that the province was initially surveyed out was that it was 6 mile by 6 mile chunks were called townships. So you can find where you are in the province, like, oh, I'm in township, 21 and whatever. We'll tell you kind of where you are. And we'll get more into that as we're doing imperial. Now today we're talking about the metric system in terms of length. So we're talking about metric system in terms of length. And the metric system at its core is a system built on tens, right? It's like 10 times bigger or 10 times smaller is how we convert from one type of metric system to another. So before we start, multiplying by powers of 10, like if we're multiplying by 100 or 1,000 or 10 or whatever, a million, we can always multiply by powers of 10 by just moving the decimal to the right or left. So let's say we have like the number, I don't know, 31.23456 or something like that. And I was asking you to take that number and multiply it by 10. We can make it 10 times bigger by just moving the decimal over to one spot. So it'd be 312.3456. Right, so this number times 10 would be this number. And if I wanted instead to divide by 10, then it would have been 3.1234. Right? So going times 10 divided by 10 is just moving the decimal to the left or right. So let's take a look here. This number, 5.4376 times 1,000. Well, 1,000 has 3 zeros, so I'm going to move this 1, 2, 3 spots to the right. So 5.4376 times 1,000 ends up being 5,437.6. And similarly, 7.8325 times 100 moves over 2 spots to the right. Right, 100 is 10 times 10, 2 tens. 783.25. And there is kind of a natural check. A number like 7 point something times 100. I'm thinking, okay, what would that multiply by 100 to get to? Well, 7 times something times 100, it better be 700 and something. And so you kind of can just intuitively say, well, does this make sense or not? Oh yeah, in this case it seems good. So how about 2.5 times 10? So you have $2.50, but then you get times 10 of that, good deal. Now we have 1 decimal spot to the right, that's 25. And next one, 19 times 1,000. Now this has a slight complication. The decimal was here. So now if I'm moving it 3 spots to the right, 1, 2, 3, it's like I've added in 1, 2, 3 zeros. 19 times 1,000 ends up being 19,000. 19 times 1,000 is 19,000. Cool. Everybody give your book? Give your book. Where is it? Beautiful. Exactly right. So dividing is the opposite. Dividing is going backwards. So multiplying by 10, we're moving the decimal to the right, then dividing by 10, we're moving the decimal to the left. So in a case like this, 75 divided by 1,000, we move it 1, 2, 3 decimal places to the left, be 0.075. And for some reason, most of us actually find this hard. It's not like intuitively it should be, but in general, lots of us will kind of get the times 100, times 1,000, but once it gets divided, we're like, wait, what's happening? So just remember, we're just doing the opposite. When we were multiplying by 10, we're moving to the right. When we're dividing by 10, we're moving to the left. So 873.9 divided by 100. We're going to move that over. 1, 2. And we're left with 8.739. 5,047.1 divided by 1,000. 1, 2, 3 spots to the left. 5.0471. 2.5 divided by 100. Okay, this is getting a little trickier because now it's going to move beyond the edge of 100. Moving 1, 2 spots to the left. Anytime there's kind of like a blank spot, just think of that you need a placeholder 0 there. So it's like we have the decimals here, so it's 0.025. And similarly, 75 divided by 1,000, the decimal was here, so you need to go 1, 2, 3 spots to the left. So 0 point, placeholder 0.75. And the interesting thing there is if we were saying this kind of in actual place value language, you could say this number as 75 thousandths, right? Because in terms of place value, it's like tenths, hundredths, thousandths. Pardon me? That is a tongue twister. I find usually using the is a little bit much for most of us. Well, we're on lesson 2.1, just working with powers of 10 to start. 75,000, moving it to the left. Okay, so far, finish thumbs. How are we thinking tens? Okay, good. That's a lot more thumbs up than thumbs down, although there's a few people just staring at me. Good. So, if metric system is mostly using units of 10, conversions of 10, then being able to multiply divide by 10 is fairly important. Now, the metric system you'll sometimes be listed as like SI units or System International. It's the metric system, that's the units like meters, grams, liters, those kind of things. That's the most widely used system of measurement. In fact, every country in the world, I think except 3, officially use the metric system. Some countries are like us in that they use the metric system, but they also use some things for imperial. But the metric system, pardon? That's right, they don't even pretend to use the metric system. Although lately we've all seen there's some interesting things happening there, so shouldn't be surprised. Okay, so in the metric system, the base unit for measuring length is the meter. Now, a reference would be something that you'd use to estimate a meter. So what we're going to start out with is thinking, how long approximately are these certain units? So a meter is something that's about a meter. So start out, try to find something in the room that's about this long. Find something that's close to that long, and list what you could be your reference for a meter. I'll give you one hint. Maybe there's something on your body. Maybe you can do this, you might be able to find something that's about a meter. Maybe you'll see some item that's about a meter. But try to write down something you might be able to think of like, okay, that's about a meter. For me, mine is like from my fingers to like the edge of my chest, it's about a meter. That's like kind of what I use when I think of a meter. But yeah, maybe I've heard lots of people say a meter is like up to your waist. So write down something that would be a meter approximately. Whiteboard. A whiteboard. Close. Yeah, close. At a desk, it's pretty close. Or write down something that's about a meter. My meter is going to be around to my hips. So for me, a meter is about around to my hips. Figure out one that's approximately directed to you. And then out of a meter, if we break it into 100 pieces, each of those are a centimeter. So if this whole thing is a meter, then each of these little tens is 1 centimeter. This is actually broken into 1,000 millimeters, this one. But if you're thinking, okay, 1,000 millimeters, 100 centimeters, 10 decimeters, would be how we break these apart. Don't want to see bones up, please. So each centimeter is about this long. This long. So think about something that's about a centimeter. What's something that's about 1 centimeter?
A pencil.
Pencil's a good one. Yeah. I got another one here. My pinky. There's certain things that kind of just over time become your reference. For me, a centimeter, mine is always just the width of my pinky. That's what I think of. You kind of find things, right? I think this is about a centimeter wide. A centimeter uniform, maybe. So if there's 100 centimeters in 1 meter, how many centimeters are there? 2 meters? Close. 100 in this?
Oh.
2,000 millimeters, so absolutely. 200 centimeters. Okay. So now we have a quick job. I have some very fancy meter sticks here. Please don't tell IKEA. What I need you to do is I want you to find a partner, and I want you to find your height in centimeters. I have marked over here 1 meter. I think it's this right here. I've marked 1 meter here. So you can do it elsewhere, but I've marked 1 meter for the ground. All of you will be taller than 1 meter. But what I would do is I'd like mark from this meter, figure out how tall you are. What you'll usually do is like just take a pen or something like that, mark it on the wall, and then measure the distance from here to here. So you can like see, I've done this for myself. For me, I've like about 79 centimeters above that 1 meter. So for me, I'm like 179 centimeters or something like that. You'll use these to measure how tall you are. If you want to just try with 2 of them instead, feel free, but it's kind of hard to hold up 2 at once. Do this in partners or in groups, go wherever you need to, and try to figure out your height. Go.